All right, so right here, when we do linear programming, we're going to have a feasible region formed by graphing a system of inequalities. I can spell this morning. Inequalities. Under these restrictions, you must maximize or minimize, which is what he did in that little video we watched a minute ago where he was plugging in the ordered pairs. And then use the vertices of the region. The vertices are what on a shape? The endpoints, the corners. Okay? All right. So here, let's look at this first one. So on this first one, we're going to go through and we're going to graph like we did yesterday, find a feasible region, and then we're going to use this, what is probably a cost equation, to find a maximum and minimum point, just like you did in that video. So I'm going to go through this pretty quickly because we should be able to graph these pretty easily by now. We're going to start this one at 4, and then is it going to point down or up? Down. Down 2, right 1. All right. As I graph it, is that going to be solid or dotted? Which is it? Solid. Why? Equal sign there, right? So it's solid. All right, so we're going to solid that in. Use your straight edge because we're going to look for vertices today, so they have to be straight because they're squiggly all over the place. They're not going to cross where they're supposed to. Use the side of your calculator, I don't know, something, your ID. You make it straight though. All right. Now, we are going less than or greater than on this one. What is that? Less than. So we're going to shade below. So I'm just going to kind of put some arrows so I know which direction to go. Everybody okay with that? So doing all the shading. So the shading is going to be below this line. All right, the next line. Y is x plus 7. Where's our starting point? 7. What's our slope? 1. Good. There's a 1 there, 1 over 1. And it should definitely point up, so it looks just like that. Solid or dotted? Solid. Got an equal sign. Come on, work with me here. There it goes. Solid. I might have to move this. Okay. All right, solid. And then is that less than or greater than? Less than. So we need to shade down in here. Everybody agree? So what you might want to do is kind of make a little note to yourself. So far, I need this triangular area here, yes? So I might put a little X here so that I know. Oh, move my little graphing screen. Don't do that. I might put a little X there so you know that this part shouldn't be shaded. What about this part? It shouldn't be shaded either. So you might put a little X in that corner so you know that corner is not shaded. Yeah, and over here, not shaded either, right? So far, we're just in here. This third one's going to tell us where to go. Now, when we graph this, see how this one's not in slope-intercept form? I can actually graph this by its intercept. Remember yesterday when we did, or last time we did intercepts? If I want to know what the x-intercept is, what did I plug in for y? 0. So let's revisit that. If I want to find the x-intercept, if I plug in 0 for y, meaning that would just disappear, right? What's x equal to? -3. Everybody agree? So the x-intercept would be -3. If I do the y-intercept, where am I going to plug my 0 in at? At the x. And so if I plug a 0 in here, I get 3y equals -3. So what would y have to be? What is it? -1. All right. So when I graph that line, I have an x-intercept at -3. Get a different color here. Everybody okay with that? And a y-intercept at -1. See how I did that? I graphed it by its x and y-intercepts. A little bit different method.
So where you shade it?
All right, so let's draw the line in. Solid or dotted?
Solid.
Solid. So it says a slope of 1/3, right? And so make sure your line goes in. Okay? All right, now, shade below or above? Now, let me ask you this. The y is positive. So is this inequality going to change or stay the same? Stay the same. So is it greater than or less than? Greater than. So that means we want greater than this line. So is that above or below the green line? Above. All right, and so now I'm just going to look at it and say, hey, where do all my arrows point to? What shape is it? Triangle. So this shape here in the middle, let's see if I can highlight this. I don't hardly ever use my highlighter. But, is it working? So this little feasible region, I'm going to shade that in dark so it looks nice and pretty. Right? So now we're going to take this little equation here and, oh, dang, I'm having some issues this morning. Try again. Okay. Take this little cost equation here and find the maximum minimum point. Okay? Jasmine, I need you to sit up back there. All right. That's right. So what's this one right here, Naya? Okay, good. Yeah, 3, -2. So we're going to look at 3, -2. What's this one right here? Yeah, look at your paper. 6, -1? -1, 6. All right, good. So left 1 up 6. And then what's this last one? You said it. -6, 1. Left 6 up 1. There we go. All right. So those are my 3 points that I'm going to check. So in my calculator, everybody turn your calculator on. I'm going to show you a little trick on the calculator. You are going to take your points. Come on, calculator. I'm going to reset second plus 7. It's in the way. 712. Did that work? No. Second. One more time. Second plus 712. All right. So in my calculator, I am going to put in, go to your home screen so I can quit. Now, somebody read me the cost equations. I can't see it. What is it?
C equals 8x plus 11y.
Okay, 8x plus 11y. So we're going to do 8x, which in this case for that first ordered pair is 3. Everybody agree? So this is what we're going to do. 8 times 3 plus 11 times -2. That's what we're going to do. All right, so somebody read that to me. 8 times 3.
8 times 3 plus 11 times
Oh, this recording box is really messing up my calculator. Plus. My recording box isn't big enough. All right, I'm going to stop recording for a second. All right, so at that point, once you plug in all those numbers, you get 2, 58, and 37. Up here it says find the maximum and minimum values. So let's start with the maximum. So if I was going to do the maximum, I'm going to do MAX. Where's the maximum point? Which one's the maximum point? The 58, right? Which is at -1,6. So we're going to say the point -1,6 produces a maximum of 58. Probably should put that in a different color so you can see it better. Do the other one different color. Now the minimum, what's the minimum point? -37, which the point would be -6,1, which produces -37. Okay? And so that would be my final answer right there. Okay? It's not too bad. Yeah, it really is. Okay, so what I want y'all to do real quick is do number 2. And we'll check it. Everybody do number 2 real quick.